Welcome back to Learning with me, Ms. Killen, here at MPB. We are still in our numbers and expressions. Today we are looking at Lesson 4, Exponents Properties. We're still in our Unit 1. We're looking at ASSE2. I can rewrite algebra expressions using exponential properties. Now, if you are taking our Canvas course, you will have a sheet in that Canvas course that you can print off and fill out, or if you are just taking this by yourself, you're going to need a piece of paper and maybe have some columns and rows so we can put these different properties together and we can have some content with that, some examples, because I do want us to know all of these properties because we're going to take them all the way through to the end of the course. Now, before we get into it, I want to show you a very important poster that I have on my wall here in my classroom. It's my exponents rule. Now, it says the exponent of a number says how many times to use the number in multiplication. Now, you see 8 up here. In our lesson today, we're only going to talk about 7, but there are 8. We have our property rule where we're multiplying, our division rule where we're dividing, a power of a power where we have 2 different exponents, the power of property where I'm splitting things up, power of a quotient, what that looks like, our negative exponents, and our zero rule. Those are the ones that we're really going to look at today. Like I said, we're going to get some rules and we're going to get some explanation for that. So let's dive on in and see what we've got. It says first, let's review. Now, when I see a to the nth, what I'm really seeing is a variable for my base. So my larger number is my base, and my number up here is going to be my exponent. So I want to make sure that we remember what is what when we're seeing these different terms. Our larger number is our base, and then we have our exponent. So then what about these? 4 to the third, 3 to the third, 3 to the second, and 3 to the first. Now, we could go 3 times 3 times 3 times 3 and so forth and so on, but we have this wonderful tool that we've got. We have our calculator. You pull up your calculator. I'm going to pull mine up on the board, and we're going to put all 4 of these in to see what they look like. So here we go. So here's my calculator, and the first one that we have on our papers is 3 to the 4th. Now, to put this in our calculators, I'm going to hit my 3 button, and then above my division button is a little housetop looking deal. I'm going to press it, and then I'm going to press a 4. So that looks just like it did on our paper, and I'm going to press enter. So 3 to the 4th equals 81. So I'm going to put in my next one. I'm going to hit 3, the housetop button, which is right above the division or right under clear, and then I'm going to put to the 3rd and press enter. 27. I'm going to do to the 2nd. 3, housetop 2, which is 9. Now, when I square something, which is the same thing as to the second exponent or to the second power, we also have a squared or to the second power over here right beside the 7 button. So I could put, here's my 3 button, and this x to the 2nd button, catty corners sort of, or diagonal to the 7, it does the same exact thing. So the more we get into our unit, the more we'll use this calculator and we'll get more familiar with it. So then I had 3 exponent to the 1st. So this is how we plug those exponents into our calculator. So we said that 3 to the 4th equaled 81, 3 to the 3rd was 27, 3 squared was 9, and 3 to the 1st is 3. Now, I have a very, very, very important question about this. Do you see any patterns? I do. Talk to your table partner. See if you see a pattern. You're exactly right. Each time I am dividing by 3. That is really neat that you saw that. So as I'm going down in my exponents, I'm dividing by 3. Good job. Now, one more question. So what would 3 to the 0 power be? Well, if we pull our calculator back up, let's see. So if I pull that calculator back up and I say 3 to the 0 power, I get a number 1. So 3 to the 0 is going to be 1. We're going to look at that a little bit more as our unit progresses. So here we go. Let's write down the exponent's properties. Make sure that you're taking note of each. They will help us with our problems at the end, and like I said, we're only going to do 7 of the 8 today. So the first one, the first property is zero exponent property. Well, this is what we just looked at on that other page. Anything, it doesn't matter how big or how small the number is, anything to the 0 power is going to be 1. That's all it is. So I have my base, and then I have my exponent. So what if I had this? What would that answer be? Exactly right. It's going to be 1. It does not matter what number our base is. If it's to the 0 power, it is going to be 1. Now, with that being said, in Algebra 1, 0 to the 0 power, we can't do. If we plug that into our calculator, it gives us an error. We're not to that portion of the program yet. That's going to be in some more math higher than Algebra 1 that we get to. But we cannot take 0 to the 0 power, but we can take everything else to the 0 power. Good job. Let's look at the next one. Okay, so if that's the pattern, let's continue. What do I notice about my exponents now? They're negative. So what do you think happens when I have a negative power? Now, we've seen what happens when I have a positive power. What do you think happens when I have a negative power? Possibly. But let's pull our calculator and see. So we're going to put this first block in to the -1, to the -2, and to the -3. So let's go ahead and pull that calculator up. So I've got 3, my exponent key, -1. I get a decimal, Miss Killen. That's okay. I want everybody to push their math button right under the green button. And see where number 1 says fraction? I'm going to press enter, enter. And I get a fraction. So I turned that decimal into a fraction. That's what I did. Let's try the next one. So I've got 3 to the -2 power. I got a decimal again, so I'm going to go to math and turn it to a fraction, or see if I can turn it into a fraction. I get 1/9. Well, just to make sure the pattern's working, let's try that last one. 3 to the -3 power. Got a decimal, so let's see if we can turn it to a fraction. Go to that math button and hit fraction. Oh my goodness. So if we go back and look at our papers, we said this one was 1/3, this one was 1/9, and this one was 1/27. Do we see a pattern? Is there something we could say for sure when you see this, this is what happens? Maybe. Let's try this next one. I want you to do this one, 4 to the -1, 4 to the -2, and 4 to the -3. Do that one on your paper. I'm going to do it up here, and let's see what we get. So I'm going to do 4 to the -1 and turn that to a fraction. 4 to the -2 and turn that to a fraction. And then 4 to the -3 and turn that to a fraction. So I get 1/4, 1/16, and 1/64. Does yours look like that? What about your table partners? Does theirs look like that? So could I make a rule that if I see something, this is what happens? What do you think that rule could possibly be? My second property, negative exponents. So when I have a negative exponent, it turns it into a fraction. That's what happens. It turns it into a fraction where the numbers are under 1, and then whatever this exponent is, that's how much I raise my base to. So like when we had 3 to the negative 1 power, that was 1. 3 to the 1 is itself. So that's what that looks like. Now, if I have 1 over a base with a negative power, it's going to come back just like when we had a base and an exponent. It's just not going to have that negative. So it kind of flips itself. All right, the negative flips the fraction, then raises to the power. That's exactly what we said. When I see that negative exponent, I'm going to flip it and make it into a fraction. If I'm still having problems with that and I use my calculator and I get this big long decimal number, I'm just going to turn that decimal into a fraction using that math key. Good job. Let's look at number 3. My third property is the product property. The property tells us that when you multiply bases, you add. Let me get a different color because I want to make sure that we see that we are adding our exponents. Even if I have a negative, I'm still going to add those exponents. Let's look at this first example. 3 to the third times 3 to the fourth. I am keeping my same base because it's a 3, and I'm adding my exponents. So 3 to the 7th is the same thing as 2,187. Miss Killen, are you sure? Pull up your calculator, and let's just put it in. I have 3 to the third. I'm going to go to my scroll key right, and then I'm going to put plus, and then I'm going to have 3 to the fourth, and press enter. And I have 3 to the 7th, which is 2,187. Good job. All right, making sure I have that 3 to the 7th. Yep, that's it. All right, so let's look at this next one. I have 4 to the 5th times 4 to the negative third. Now, even if it's a negative, I'm still going to add them. So I'm still going to keep this base. So 5 plus a negative 3. Miss Killen, I'm still struggling with that adding and subtracting different signs. That's okay, because we have a calculator. I'm going to put in 5 plus negative 3. Remember, my negative is under the number 3, and I get 2. So this is going to be 4 to the 2nd. Now, I have a variable. Miss Killen, is it going to be different if I have variables with exponents? No, it's not. I'm still going to keep that base, and I'm still adding those exponents. 3 plus 2 is 5. So if we look up here for the prime example of this property, I'm using a to the m times a to the nth, and it shows you right here that I add those exponents. Good job. Make sure that you're writing these properties down. Make sure you're writing what the names are and giving a little bit of detailed what that means, and then we're putting an example or two. Because I can write something down all day long, but if I don't know what I'm talking about, it's just words on a paper. So you're wanting to make sure that you're putting these examples down. All right, let's look at the next one, number 4. Oh, now let's try our hand at division. All right, so we are going to be dividing terms with exponents and the same bases. So let's see what that looks like. Our fourth property, the quotient property. When you divide bases, you subtract. Make sure you understand you are subtracting. Highlight or circle or whatever, you are subtracting those exponents. If left with a negative number, always make sure you take it into a fraction. So let's look at this top one up here. 5 to the 5th divided by 5 to the 3rd. So this is how I have worked mine in the past, okay? So I want to show you this. So I have, and let me get a different color that we can see clearer. I have 5 5s that I'm multiplying on top. 3, 4, 5. Now, on the bottom, I have 3 5s. Now, we said that we are subtracting. So this is what I do. This helps me until I understand, oh, I got to subtract. 5 minus 3 is 2. So I'm going to show you an example of it exactly equals 2. So watch. I'm subtracting 1 from top and bottom, subtracting another from top and bottom, subtracting another from top and bottom. So I am left with 5 squared, which equals 25. That is just another tool that we can have to subtract those or see how they're canceling each other out. So let's look at the next one. Oh, this one's going to be a little different. So let me get a different color. I'm all about the colors. So let's do purple. So I have 7 x's that's being multiplied to each other on top. 1, 2, 3, 4, 5, 6, 7. Now I have 8 that's being multiplied to each other on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. We're going to do the same thing that we did and subtract them. I'm subtracting this one, this one, this one, this one, this one, this one, this one. Oh, I'm left with 1 on the bottom. How do you think that I can show where I only have 1 on the bottom? Talk to your partner. All right, see if y'all came up with this. I have 1 left, but to make a fraction, I always have to have a numerator. Well, if I don't have an x to put up there, I can put a 1. So that's what I have left. I have 1x left on the bottom, so I'm left with 1 over x. And that is how we use that quotient property. Good job. Okay, so let's look at the 5th property, powers of a power. So our definition tells us a to the m raised to the nth tells us that we're going to multiply our 2 exponents. If an exponent is raised by another exponent, we multiply the exponents together. So let's look at this first one, 3 to the 2nd to the 3rd. So I'm going to multiply my 2 and my 3. So I keep my base, and I will have 3 to the 6th. Now let's look at the next one. I have a base of x. I am still going to use the same principle. I'm still multiplying those powers together. So my base is x, and 3 times 4 is 12. So I have 3 to the 6th because I multiplied my 2 exponents, and I have x to the 12th because I multiplied those 2 exponents. Let's try one more just to see what we've got. So let's say I have 9 to the 4th, and we raise this to the 7th. Now, what would that look like? Obviously, I'm going to keep my base, and then I'm going to multiply my 7 and my 4 together to get that 9 to the 28th. Now, if we put that in our calculator, obviously that is a really big number. So let's try yet one more. Let's say we have y to the 2nd, and we raise it to the 12th. I'm going to keep my base of y, and I'm going to multiply those 2 exponents. 12 times 2 would be 24. And this is our 5th property, the power of a power. Let's look at number 6, power of a product property. We are doing a reverse of multiplying when we are just basically splitting them up. So when I have a times b to the nth, basically I'm showing you that a to the nth times b to the nth. That's all we're showing is a to the nth times b to the nth. So now let's look at the white box. So you may also see them look like this. So again, we're showing 3 squared times 4 squared. I'm just splitting them apart. So you and your table partner do that last one while I do it up here. And check to see if mine looks just like yours. These are getting really easy, really simple. With these examples, they're showing us how we're using these properties. Good job. All right, let's go to number 7. Power of a quotient property. What about the quotient raised? Okay, so now we are raising both the denominators and the numerators. So Ms. Killen, what does that look like? That shows us that a to the nth and b to the nth. So let's look at an example that shows us that. We're going to use 21 over 4. So I have 21 raised to the 3rd power over 4 raised to the 3rd power. So what if I had one that looked like this? How would I write that? Yes. So it's going to be t to the 4th over 7 to the 4th. Y'all are really catching on to these. I think it's helped that we've seen the property, we've given the definition with our A's, our M's, and our N's, then we've given those examples. So we've been doing our let's do some practice along the way. So the reason I said that, now it's time for you to master. This is when you show me and everybody else, you've learned what we've been doing. So what we're doing is we are using the properties that we've learned to match the expressions on the left to their equivalent expressions to the right. Now, go ahead and pause the video. You by yourself or you and your table partner or whatever, y'all go ahead and work these. And then once you've got your math and once you've figured out which ones are equivalent, come back to me and let's see what we got. All right. So here we go. Let's see what we got. I've got 6 to the 4th, or excuse me, 6 over 3 to the 4th. So how am I going to look at that? Well, let's break that up. 6 to the 4th over 3, let me erase that 6. Oops. Let me see if I can get this erased. There we go. All right, so I'm going to put that to 3 to the 4th. Now, which one looks like that? Exactly right. That's going to go to number 2, or if you wrote number 2 beside A. Good job. Let me get a different color. Let's do black. All right, 6 times 3 squared to the 3rd. Now, what does this one look like? Well, let's see. 6 is going to be raised to the 3rd times 3, but now I've got a power being raised by a power, so I'm going to multiply them. So 3 times 2 is 6. Which one looks like that? Number 1. Good job. So I'm going to put a number 1 there. Let's get a different one. Let's do red. All right, so I've got 6 squared times 6 squared. Well, what does that one look like? When I'm multiplying with the same base, I add them, so it's going to be 6 to the, 4th. So where does that? There it is, right there. So C is 4. Now look at D. Anything to the 0 power is what? 1. So I'm going to go ahead and put a 1 right there. So 6 squared times 1 is what? 6, whoops, not quite like that. 6 squared, and it looks like that. All right, 2 more. Let's do, I guess we'll do orange. All right, so I've got a fraction, and I have a fraction that I'm going to make because I have a negative exponent. So if I have a fraction, and I know I'm going to make another fraction because I've got a negative, how do you think that's going to work? How do I make a fraction a fraction? I flip it. Exactly right. So let's see what that looks like. It's going to flip to 3 over 6, and then I'm going to put them to the 4th. So it's going to look just like number 3. That was a good job. All right, last one. Let's get our last color. We'll do this one. Okay, so I have 6 to the 6th divided by 6 to the 3rd. Now, we said when we divided, what do we do with our exponents? I subtract them, okay? So here we go. 6 to the 3rd. So that one is going to go straight across, and that's number 6. Check my math, check your math, and see what you got. Did we do the same? Did you get when we flipped the fraction? Did you get when we got a 1 for our 0 power? Make sure that you are looking at your powers and you're looking at your problems so you can use those comparisons. Good job. All right, so something that we don't want to forget. We do not want to forget those 7 properties of exponents. We want to know how they look when we have to give them as equivalent expressions, which means the same expressions. We also need to know, what do we do when we must use negative exponents? Remember, we're taking those negative exponents and making fractions. And as we saw, when I have a fraction to a negative exponent, I'm just flipping my fraction. And we're always looking for patterns in math, always, always. I am so glad that you came to learn with me today here at MPB. I'm having a great time learning this with you. I want you to have a great day.